Everyone is hot, or rather, everyone has heat. Every atom and molecule in your body undergoes constant random motions that are impossible to predict. These random motions are what we call heat energy. Thermodynamics is the study of the movement of heat. If you touch a block of ice, it isn't always pleasant unless it's a really hot day. If you touch a hot pan out of the oven, you'll burn yourself. Both of these things happen because of how fast heat is moving. The heat from the hot pan moves into your hand rapidly, and when touching an ice cube, you lose your own body heat fast. Heat transfers from hot places to cold places, or in other words, heat spreads out. Extreme heat or cold can damage our tissues, so it's a pretty important thing to understand. It's also how we've been able to build refrigerators and large insulated coolers to take to the beach. These are examples of the many things we can do with heat if we understand how it moves within or between systems. A system is just a particular object or area we're looking at. Our system could be the inside of a thermos flask, or it could be the whole human body, or just our skin, or the gas inside a piston. We choose the system we want to look at for convenience. Then we can look at how heat moves in, out, and within that system. We can look at how the system changes. A thermodynamic process is any process that involves heat energy moving within a system or between systems. In this lesson, we're going to look at the 4 types of thermodynamic processes. The 4 types of thermodynamic process are isobaric, isochoric, isothermal, and adiabatic. Those terms are pretty hard to understand just from the names, so let's break them down one at a time. An isobaric process is one where the pressure of the system, often a gas, stays constant. Iso means the same, and baric means pressure. Pressure is related to the amount of force that the molecules apply to the walls of the container. Imagine that you have a gas inside a movable piston and you heat that gas up. By heating the gas up, you make the molecules move faster, which would normally increase the pressure. But at the same time, the piston expands, increasing the volume and giving the molecules more room to move. Since the walls of the container are now bigger, the pressure can stay the same, even though the molecules are moving faster. That makes it an isobaric process. An isochoric process is one where the volume of the system stays constant. Again, iso means the same, and choric means volume. Volume is the amount of space the material takes up. So this would be like heating a gas in a solid, non-expandable container. The molecules would move faster and the pressure would increase, but the size of the container stays the same. An isothermal process is one where the temperature of the system stays constant. Thermal relates to heat, which in turn is related to temperature. Temperature is the average heat or movement energy of the molecules in a substance. An example of an isothermal process would be if we took a gas held behind a movable piston and compressed that piston. The volume has decreased and the pressure behind the piston has increased, since the molecules have less space in which to move. When you compress a piston, you're using energy. You're doing work on the gas, so normally the molecules would gain energy and move faster, and the temperature would increase. So the only way for an isothermal process to happen is if all that energy you put into compressing the gas comes out again. For example, by putting a cold reservoir in contact with the piston. In an isothermal process, whatever energy we put into the system immediately leaves the system again. In the real world, you would have to move the piston infinitely slowly to make this happen, but you can still do something that gets close to this by moving super slowly. An adiabatic process is one where no heat flows in or out of the system. We can't heat up the system by putting a hot reservoir next to it, and we can't cool down the system by putting a cold reservoir next to it. The system is perfectly insulated. In an adiabatic process, you take the gas behind the piston and move it up or down to change the volume, and both the pressure and the temperature change as a result. If you compress the piston, both the temperature and pressure increase because you've added energy to the system by doing work, pushing the piston down. If you let the piston expand, both the temperature and pressure decrease. For this to happen in real life, you would either need a perfect insulating material or you would need to push the piston infinitely fast. Thermodynamics is the study of movement of heat, which is the motion of molecules. A thermodynamic process is when heat moves, either within systems or between systems. There are four types of idealized thermodynamic processes. An isobaric process is one where the pressure stays constant and the temperature and volume change relative to each other. An isochoric process is one where the volume stays constant and the temperature and pressure change relative to each other. An isothermal process is one where the temperature stays constant and the pressure and volume change relative to each other. An adiabatic process is one where no heat flows in or out of the system. Pressure, volume, and temperature all change relative to each other. Together, these four processes help us understand how heat moves. Although many of them are not possible in real life, by understanding these idealized situations, we can better understand the more messy and complex situations in the world around us.